Hello YouTube, this is Sam from Tiger Schooling, and in this session of the video we're going to talk about all the vitamins. So in order to talk about all the vitamins, first we need to know about the vitamins which are present and which are required by the human body and which are really important. So we are going to cover up each and every vitamin in a precise manner, and we are going to cover up the main things regarding vitamins. If anybody is going to ask you about any vitamin, so you will be definitely having an image in your mind about that vitamin, and you could picture out all that vitamin in your daily life, and you can make it as easy as possible, and you remember them all in the end. So I want you to stay with me till the end in order to understand all the vitamins. So let us begin the discussion regarding the vitamins. So we have got the vitamins, and we divide the vitamins into two parts, that is water soluble vitamins and fat soluble vitamins. Not so much complicated. These vitamins are soluble in water and these are soluble in fats. So in water soluble vitamins we have got mainly two types of vitamins, that is ascorbic acid, which is vitamin C, and we have got vitamin B. So vitamin B, C are in water soluble, but in vitamin B we have got a bunch of vitamin B vitamins, so which are we call the vitamin B, we call the vitamin B complex. So there is a complex, there are many vitamin B vitamins in the water soluble types. So we have got number one, the B1, which is thiamine. We're going to come to discuss each one in detail in just a bit, but just give me a quick review regarding the name. So this number B1 thiamine, B2 riboflavin, B3 niacin, B5 pantothenic acid, B6 pyridoxine, B7 biotin, B9 folic acid, and B12 cyclobalamin. And again, moving towards the fat soluble vitamins, we have got only 4 fat soluble vitamins. I've already made a quick review video about these vitamins and their naming. You can check that out in the description. So fat soluble vitamins, we have got vitamin A, vitamin K, vitamin E, and vitamin D. So these are the basic differentiation between the water soluble and the fat soluble vitamins. So there's nothing complicated, it's very easy. This is all you have to remember for your exams, for whatever you got. This is the main thing. You don't have to worry about opening up a book and finding a new vitamin. There could be small types of vitamins, but these are the main major vitamins. So let us begin with the water soluble vitamins. So in the water soluble vitamins, we're first going to discuss about the ascorbic acid, which is the vitamin C. So you will be wondering why vitamin C is called ascorbic acid. It's because it was named ascorbic acid because of its anti-scorbutic activities. So what is anti-scorbutic activities? Which means it prevents against scurvy. So scorbutic is scurvy, scorbutic is scurvy. So it prevents from against the scurvy. That's why it is called ascorbic acid. So it's also called as the vitamin C. Alright, so vitamin C is actually very important. One thing you have to remember, they ask you vitamin C on boiling. Actually, if you heat it much more, it will destroy itself. Even in milk, it is present. The vitamin C is present, but most of the people in the home, they like boil the milk too much. So that's why the vitamin C is destroyed, and you can't get the vitamin C through milk. So you have to remember this one as a good point, that vitamin C is actually destroyed on excessive heating. So further talking about the vitamin C, we have to remember these things that I have written in the bullet points. So first point is polyl and lysyl hydroxylase. So what does that mean? So that means that vitamin C actually acts as a coenzyme in hydroxylation of what? Of proline and lysine. Again, ascorbic vitamin C acts as a coenzyme. Remember, I'm using the word coenzyme. It does not act directly. It acts as a coenzyme in hydroxylation of proline and lysine, so which are actually the residue of the collagen. So that's why this thing will be going to help us in understanding the scurvy. So you have to understand this. All right, we are clear with the first point. Hydroxylation of proline and lysine is actually helped by there's a extra vitamin in which the vitamin C acts as a coenzyme. Number 2 point is the collagen synthesis. So what does that mean? What that means that it helps in the synthesis of collagen. So how does it help in the synthesis of collagen? We're just going to talk about in just a bit that how does it help in the synthesis of collagen. Number 3, we have got the iron absorption in GIT. So what does vitamin C does? It actually convert the you can say it reduces the iron from ferric form to the ferrous form and helps in the iron absorption from the intestine. So you can say the ascorbic acid also help in the iron absorption in GIT and convert the ferric form, or you can say it actually reduces the ferric form, which is 3 plus, to the ferrous form, which is 2 plus. That's it. Help in iron absorption and in GIT, and also it actually reduces the iron from ferric form to the ferrous form. Alright, this is the basic idea regarding this one. One thing I haven't mentioned over here is that vitamin C also helps in the conversion of folic acid to tetrahydrofolate, that is THF. The number 4 point that is regarding the vitamin C is actually the scurvy. So what is scurvy? So scurvy is actually caused by the deficiency of the vitamin C. When vitamin C is deficient, we have got a clinical deficiency, which is the scurvy, which results in. So what are the causes of scurvy? So there are actually 2 main causes regarding the scurvy. The first point you can say the first cause is actually reduced, or you can say deficient, or you can say reduction of folate to THF. So we need tetrahydrofolate, that is the active form of folic acid. We don't need folic acid because it does not act directly. So we need tetrahydrofolate. So this actually in scurvy it is not converted because vitamin C helps in converting the folic acid to tetrahydrofolate. So when the vitamin C is absent, so what happens? Tetrahydrofolate does not form and result in the inability of RBCs to mature, right? And number 2nd point, that is, it is the deficient hydroxylation of collagen resulting in defective connective tissue. What does that mean? So what that means that polyl and lysine are not going to hydrolyze, so not going through a process called hydroxylation. If they don't go, they're not going to make a collagen strong, or they're not going to make a collagen. So for the collagen to be synthesized, these should be hydroxylated. So it is not happening, it is going to have a problem, and these 2 things, that is the THF is not forming and the polyl and lysyl hydroxylation is not occurring, then there are the 2 main causes of the scurvy. We're not going to detail about any detail regarding scurvy, but we have to understand that in scurvy the blood vessels become fragile and may spontaneously bleed anywhere in the body. So there are a lot of symptoms of scurvy. We have already made a lecture on it. You go through, and we're going to just make a quick video, regarding all vitamins. So now let us move towards the thiamine. So the thiamine is actually B1, vitamin B1. So it's active form. You can say this is not an active form. But TPP is an active form, which stands for thiamine pyrophosphate. So which is actually a coenzyme of thiamine. So this TPP, or the coenzyme, is used in the oxidative decarboxylation of pyruvate by pyruvate decarboxylase. So the pyruvate decarboxylase actually is an enzyme which uses a coenzyme, which is that TPP, which actually help in the oxidative decarboxylation. So oxidative decarboxylation is a reaction. Oxidative decarboxylation is a reaction, and pyruvate decarboxylase is a coenzyme, which is actually which is an enzyme, and in which the coenzyme is TPP, or you can say the thiamine pyrophosphate. So the other enzymes which also require this coenzyme are pyruvate dehydrogenase. These are really important. You have to remember them. The pyruvate dehydrogenase and pyruvate decarboxylase. All right. So in the case of deficiency of vitamin B1, or you can say thiamine, we are going to have a problem that is named as beriberi, or you can say WK syndrome, or full form is Wernicke-Korsakoff syndrome. I'm sorry about my pronunciation, but it's Wernicke-Korsakoff syndrome. beriberi and Wernicke-Korsakoff syndrome. So in beriberi we have got two types, that is the dry beriberi and the wet beriberi. So you have to remember it like this: dry beriberi and the wet beriberi. So the dry beriberi, this is the problem of the deficiency of B1 thiamine. So in the dry beriberi, like beriberi is divided into two, which is the dry beriberi and the wet beriberi. So remember it like one: wet, your blood is wet, right? So this wet beriberi is going to affect your circulatory system and heart, because you have got blood in your body, so it's heart which is filled with fluid. So you can say wet, it's wet, right? So wet beriberi affects your heart and, right, you got it right, circulatory system. And your dry affects your nervous system. Just remember it till that. You have to look over other details in the in your whatever books or whatever sources you're reading. This is enough for the regarding this lecture. And in the WK or Korsakoff syndrome, you have to remember this is a neurological disorder which actually affects your hypothalamus and these the other parts of your brain, and it also causes a memory loss and other problems in your hypothalamus. All right, now let's move towards the B2, which is riboflavin. So in order to remember riboflavin, one thing have to be clear, that riboflavin or B2 is actually giving two coenzymes, that is FAD and FMN. You have heard of them a lot of time. So FAD stands for the flavin adenine dinucleotide, and FMN stands for the flavin mononucleotide. So these are two coenzymes. Remember this one. So you just define it this way: riboflavin forms two biological active coenzymes, that is FMN and FAD. You have to just remember them. Riboflavin, always remember FAD and FMN, those two, that is flavin mononucleotide and flavin adenine dinucleotide. Alright, this is the main characteristics of the riboflavin, which actually help in the redox reaction, or you can say it actually helps in the FM and FA help in the redox reaction and take part in the synthesis of ATP and all that, because they are reduced forms, and their reduced form are, you know, that FMNH2 and FADH2, as they have again the hydrogen in their forms, right? So other thing that I have to discuss is the in the deficiency. If you go through the books and websites, you don't find that in the deficiency we have got anything, but there are several things that are, when the riboflavin is deficient, several symptoms are going to show up. That is the angular steomatitis. That means that on the sides or on the corners of your mouth, you're going to get a little bit, your corners of your mouth might get a little inflamed and widened. So that's why it's called angular, on the angle side, steomatitis. And dermatitis, you get inflammation of your skin and all the problems of your skin because of the deficiency of the riboflavin. Now let's move towards the another enzyme, that is the niacin. Similar to the riboflavin, you have remembered FAD and FMN. In the niacin, you have to remember NAD and NADP. Those both are really important regarding the niacin, because these are the actually biological active, or you can say, define it this way. All right, define it this way: niacin produces two biological active forms of coenzyme. These are both coenzyme. These were both also coenzyme. Define it this way: niacin produces two biological active forms of coenzyme, that is nicotinamide dinucleotide and nicotinamide adenine dinucleotide phosphate. Got it? That's it. These are two major coenzymes produced by are actually a biological active form of the niacin. And now let's discuss more about the niacin in just a bit. So one thing you have to remember, they mostly ask in MCQs, BCQs, and a lot of the time teacher asks you in your viva. So you have to remember that tryptophan, when there is a 60 milligram of tryptophan, it actually gives off 1 milligram of niacin. So if you convert tryptophan 60 milligram, you are going to get 1 milligram of niacin. That is correct. And another thing you have to remember regarding the niacin, that it actually inhibit the lipolysis. So what does that mean? So that means It strongly inhibits the lipolysis in adipose tissues because they are the primary producers of circulating free fatty acids. So these are the primary producers of the the circulating free fatty acids. So this point is also clear. Another thing we have to remember is actually it is used in the treatment of the hyperlipidemias. This thing have to be remembered. 4 things regarding niacin: tryptophan, when 60 milligram of tryptophan converted to niacin, 1 milligram we are getting. It inhibits the lipolysis treatment of lipopeninemia. And one thing more regarding is clinicals. So regarding the clinicals, we have to remember our symptoms, or you can clinical notes. You have to remember the word 3Ds. They mostly ask about 3Ds. Which vitamin is also called 3D, or which in which vitamin deficiency we are going to get a symptom of 3Ds. So the symptom in this case we have got because in the what happens, look, let me define again. In the case of deficiency of niacin, we're going to get a disease, or you can say we're going to get a clinical condition that is pellagra. So what happens in pellagra? We're going to get 3Ds, which is a symptom. So 3Ds, and what happens in 3Ds? We got dermatitis, inflammation of skin, we get diarrhea, and we get dementia. All right, finally death. That's another point. So in pellagra deficiency, we have got 3Ds. That is dermatitis, diarrhea, and dementia. That is all the story about the niacin. Now let's move towards the pantothenic acid. There is nothing much more about the pantothenic acid. It's just a quick review regarding the pantothenic acid. So what you have to remember regarding the pantothenic acid, we have got riboflavin, FAD, FMN, coenzymes. Again, what we get here in pantothenic acid, we're going to get a coenzyme. Remember, in the B1, B2, B3, there is no B4. We're continually coming. I have searched for the B4, but there was no enzyme. There was no vitamin named as B4. So you're going to jump up from B4 to B5. That is a pantothenic acid. And again, we are going to get a coenzyme. Exactly. So the pantothenic acid provides coenzyme A, which actually helps in transfer of acyl groups. All right. Pantothenic acid, we're going to get a coenzyme, which is called coenzyme A, which actually helps in the transfer of acyl groups. That's it regarding the pantothenic acid. So one thing more to add up in the pantothenic acid, which is it is also a component of fatty acid synthetase. Remember this one. This is an extra point. You have to remember it. So whenever somebody says what is the which vitamin is the component of the fatty acid synthetase, you're going to directly answer them with that is the pantothenic acid. That's it. All right. Just very easy, quick review regarding the pantothenic acid. I'm just lengthening the lecture in order to remember you, but make sure it's very easy. It's not that much difficult. So number 6, we have got, or you can see vitamin B6. We have got pyridoxine. So all right, the pyridoxine, and very interesting vitamin. Not that much, but it's kind of interesting. So the pyridoxine actually, you can say it's a B6 vitamin. So it have got different, the forms that have got pyridoxamine, or you can say, but the biological active or the coenzyme is actually the coenzyme pyridoxal phosphate. Similar, we have got coenzyme here, coenzyme here, coenzyme here, coenzyme here. In the B1, we are going to get all coenzyme. In the coenzyme pyridoxine phosphates, which actually, this is actually going to help us in the protein catabolism. Remember, in the protein catabolism, if they're asking you which vitamin actually major vitamin going to help you in the protein catabolism, you're going to answer them that it's the pyridoxine, or you can say the biological active form, that is the coenzyme pyridoxal phosphate. All right, I've mentioned here TB. I didn't mean anything that causes TB or something else, but there was a related thing I have to explain regarding this vitamin. So what happens? There is a drug. It is named as isoniazid, which is also short form as INH. This is a drug. When this drug is actually prescribed to patients having tuberculosis. So when you are giving a person this drug INH or to treat TB, so what you have to do, you also have to give that patient vitamin B6 or pyridoxine, because the isoniazid or an INH, a drug used in the treatment of tuberculosis, can cause vitamin B6 deficiency. Remember this thing. if you're going to give this one, this is going to cause the deficiency of vitamin B6. So you have to give an extra supplement to the patient in order to meet up the vitamin B6 requirement. All right, so this is all about vitamin B6. Now let's move towards the biotin, which is the vitamin B7. Vitamin B7 seems a little bit, known, the word biotin, most of the time we hear it. So what you have to remember, in similar sequence, we have got a coenzyme. So in this case, there is a special thing. So the biotin is actually a coenzyme of carboxylase. It is not going to give a coenzyme or the active form. This is itself is a coenzyme of carboxylase. So carboxylase is an enzyme which is a coenzyme that is biotin. So biotin is actually a coenzyme of carboxylase. So it actually helps in the carboxylase, or you can say in adding carbon dioxide in certain chemical reactions. Now let us move towards the folic acid or tetrahydrofolate. That's a deep lecture that need another lecture, but I'm going to make it short and easy in order to make you remember to make it easy for you to remember this folic acid. So what is folic acid? So folic acid is vitamin B9, which is not an active form. The active form of vitamin B9 is tetrahydrofolate. So when folic acid goes through two-step reaction, it's going to convert into the tetrahydrofolate. So the conversion of folic acid into tetrahydrofolate, we need two important things. That is the vitamin B12 and vitamin C, which is also called as the ascorbic acid. So remember, tetrahydrofolate is not going to be formed from folic acid directly because we have discussed it here. So we need ascorbic acid and cyanocobalamin to help this guy to form the tetrahydrofolate, because this is going to play an important role. Because if it is deficiency, we're going to get megaloblastic anemia. So folic acid also helps in the 1-carbon metabolism. So what is 1-carbon metabolism? All right, wait. 1-carbon metabolism, I have to make a real different, extra lecture for explaining the 1-carbon metabolism in detail. So at this point, we're just going to avoid it. You have to remember it, that 1-carbon metabolism is actually, folic acid actually also causes the 1-carbon metabolism. And I have described here purines and pyrimidines. So what does that mean? So that means that means that tetrahydrofolate is essential for biosynthesis of purines and pyrimidines bases. Especially, there's one thing I haven't wrote, that especially thiamine. You have to remember this, especially thiamine. All right, I'm just not going cross line, just fast. All right, especially thiamine is going to, that's why I made this lecture is easy, because I don't want to mess up the board, because I'm too fast in writing and I just don't know what I write. I just write it fast. All right, where I was, purine and pyrimidines. All right, I have made it clear. This tetrahydrofolate actually helps in the formation of purine and pyrimidine, which is actually helps in the which are actually the nitrogenous bases, which are essential for DNA synthesis. That's why you're not going to mess up with the DNA. If you're going to mess up with the DNA, the megaloblastic anemia is going to form. So I'm going to make it quick, all right? How the megaloblastic anemia is going to form? If you have deficiency of tetrahydrofolate, even we have got folic acid, if you don't care, if you don't got cyanocobalamin, if you don't got ascorbic acid, tetrahydrofolate is not formed, and we need tetrahydrofolate at any cost. So what is that? If this guy is not present, we are going to get megaloblastic anemia. So what happens in megaloblastic anemia? The RBC, the purines and pyrimidines are not going to form. So there is a problem with the DNA, with the replication. So DNA is not going to be mature. So the RBC cells, which are present in your bone marrow, are not going to be mature. So your body needs blood. So if the immature, because the tetrahydrofolate helps in the maturation of RBCs. If those RBCs are immature, because the tetrahydrofolate is not present, but blood needs, so the circular system needs blood anyhow. So these cells immaturely get into the circulatory system and those cells are immature RBC cells. So they cause the megaloblastic anemia, because megaloblast is in a stage, is the stage of the formation of the blood. So that's why we call it the megaloblastic anemia. This was a brief lecture combining the folic acid, cyanocobalamin, and ascorbic acid, which are actually important in converting the folic acid to the tetrahydrofolate. So that's it about the folic acid. Now let's move toward the psychobilin. I'm sorry if I'm speaking fast, but this is how I do it. All right, now let's talk about the vitamin B12, which is psychobilin. Really, I mean, this vitamin is easy to remember compared to other vitamins because this guy have got cobalt in it. So no vitamin, all the vitamins, nobody got cobalt in its structure. This guy called psychobilin, so you can see there's a psycho, he's a psycho. So we have got CO. So it's a cobalt containing, or you can also call the psychobilin, the vitamin B12, you can also call it the extrinsic factor. So we have got cobalt containing, this guy is a cobalt containing, and is actually not present in plants. So that's why I see, look, there are different things. All these vitamins are present in plants, but this guy is not present in plants. So this thing is what separates him from other vitamins. Cobalt containing, not present in plants, and synthesized intestinal flora, like it is synthesized in your intestine or in animal's intestine. It's also present, it's also formed in the chicken intestine. So when you're going to eat a chicken, so you're going to get up because it's synthesized by the bacteria present in your intestines, or not by your self-intestine. There are guys sitting inside your intestine, bacteria, they're going to actually form this vitamin that is psychobilin. All right, so absorption, I have wrote it's an intrinsic factor. So we need intrinsic factor in our intestine, especially in the stomach. In the stomach we need an intrinsic factor which actually helps in the absorption of psychobilin. If the intrinsic factor is not present, we're not going to get psychobilin. One thing I have to make it clear: if psychobilin is not present, we're going to get an anemia, which is called as Megaloblastic Anemia. But if intrinsic factor is not present, it is called as Pernicious Anemia. Look, psychobilin is in we have got psychobilin in our intestine, but we are not going to absorb it because we haven't got intrinsic factor. So if we haven't got intrinsic factor, we are going to get an anemia due to this, which is called Pernicious Anemia. So whenever anybody is going to ask you what is the difference between megaloblastic and pernicious anemia, be really simple. In megaloblastic anemia, we're going to, if we don't have psychobilin, folic acid, or vitamin C, we are going to get a megaloblastic anemia. If we don't have intrinsic factor, we're going to get pernicious anemia. So this intrinsic factor is only concerned with the psychobilin, not anything else. All right, and it also, I have mentioned it again here, it also helps in the conversion of folic acid to the tetrahydrofolate. All right, now let's move towards the fat-soluble vitamins. So fat-soluble vitamins are easy compared to, because this is totally mess up B1, B2, B3, but this is very easy, guy, because we have got vitamin A, vitamin K, vitamin E, and vitamin D. That's it. So important vitamins are vitamin A and vitamin D, and I have wrote all the important things regarding these vitamins, and I'm not going to talk any detail about these vitamins. I have already made a detailed lectures on vitamin A. If you have seen other lectures, you can find out the lectures regarding vitamin A in detail, all those functions. All right, I'm just going to make a quick review, or easy thing on understanding the fat-soluble vitamins. So starting from the vitamin A. So vitamin A is actually also called as retinol, which I haven't mentioned. You can name the vitamin A into three names. Vitamin A, also called retinol, retinoic acid. I made a lecture on it, you can check that, and retinol. All right, and again we also call it beta carotene. So beta carotene is actually absorbed from plants. If you're getting the vitamin A from plants, it's in the formation of beta carotenes. Then the beta carotene actually broken down, and when it is broken or hydrolyzed, it gives 2 mole of retinol. Alright, let's start with the carotenemia. So in order to understand the carotenemia, I have to give a good description about why we are coming to the carotenemia. So listen to me. Among the carotenes, actually, the beta carotenes, which I have already talked about them, are the most efficient precursors of vitamin A. So carotenes do not have any vitamin A activity because they are not the biologically active form. The biological active form is retinol, retinoic acid, but in some cases retinoic acid is also not that much good. Retinol and retinol, that is an aldehyde and alcohol, are actually good active forms of the vitamin A. So the carotenes do not have any vitamin A activity. They are converted to active vitamin under the influence of thyroxine. That's it. You have to remember this one. Carotenes, beta carotenes are converted to the active form, the retinol, you can say, under the influence of thyroxine. So since thyroxine is required for the conversion of carotenes to vitamin A, which is an active form, so in thyroxine deficiency, if you have got hypothyroidism, you know carotenes accumulate in your blood, so resulting in a condition known as carotenemia. So carotenemia means your blood level of the carotene increases in your blood because it is not going to be converted into the active form. So carotenemia accumulates in your blood, so that condition is called as carotenemia. Another function of the vitamin A is actually in visual cycle. It helps in your visual cycle. That means it helps to see you in dark and dim light. You know, it also helps you. I have made a lecture on it. You can see that. It also helps you maintain the epithelium or your skin. It helps to protect from keratinization. And again, remember one thing more that I have really highlighted over here. That is the no retinoic acid to pregnant women. So what does that mean? You don't have to give the retinoic acid to a pregnant woman because the retinoic acid is actually is not that much active form. The retinol is a good one. You should give it her the retinol and the retinol, but not the retinoic acid. There's a thing in it because retinoic acid is inactive in maintaining normal reproduction and visual cycle. Remember this one. Retinoic acid is inactive in maintaining normal reproduction and visual cycle. So animals, you know, if any animal is given vitamin A only as retinoic acid, if vitamin A is given as only as retinoic acid from birth, will be blind and sterile because it's going to do a problem with your reproduction and your visual cycle. And vitamin A also helps in your gluconeogenesis, formation of glucose from other compounds. So if you have a deficiency of vitamin A, you are going to get night blindness because it helps in visual cycle. No vitamin A, night blindness. These are important things. Xerophthalmia is similar. We have got Bitod spot. So what is Bitod spot? It's a kind of a spot in your eye. You know, you can see that black thing in your eye. So it's a Bitod spot is formed. The xerophthalmia again in the deficiency of vitamin A. Xerosis, problem with your skin. You know. Now let's talk about the vitamin K, which is considered as, you can remember that one by coagulation. All right. So vitamin K coagulation helps in your the conversion of prothrombin to thrombin in your factors, in your clotting factors. And different clotting factors 7 and other clotting factors. So I'm keeping it light, very easy, so you just get it. Vitamin A helps in coagulation. Those prothrombin, thrombin, you must have an idea regarding them one. And another thing which is also a function of this vitamin K is actually helps in the gamma carboxyglutamate. So what is gamma carboxyglutamate? Let me talk about this. So let me add this coagulation gamma carboxyglutamate together, so to make it as easy as possible. You know, the vitamin K is actually required in the hepatic synthesis of prothrombin and the blood clotting factors that I have discussed, 2, 7, 9, and 10, and protein C and S. So to be active, these clotting factors require vitamin K dependent. What is this? This is vitamin K dependent, that is a gamma carboxylation of the glutamic acid residues present in these clotting factors. So these clotting factors are actually with the gamma carboxylated glutamic acid residues in them are the mature clotting factors. If you have got the gamma carboxylated glutamic acid, so they are considered as the mature you can say that clotting factors. So these two things are important regarding helping the coagulation of the vitamin K. Now let's move towards the vitamin E. That is also the active form is alpha tocopherol. That is the active form of the vitamin E. So you have to remember a few things regarding it. It is the strongest. I wrote strong only, but it's the strongest among all the vitamins comparing with the antioxidant. We have got ascorbic acid, which also acts as an antioxidant, but this one is the stronger than other antioxidant vitamins. All right. So it's also help in the prevention of oxidation of LDL. Three things. Alpha tocopherol is the vitamin A A active form, a strong oxidant. That's the main point regarding it. All right, and they can actually prevent the oxidation of LDL. Mostly they ask you in MCQs or in your BCQs that which vitamin actually prevent the oxidation of LDL. So this is this one. So last but not the least, vitamin D. All right, so vitamin D, the active form is 1,2,5 dihydroxy D3 active form. A bit confusing, but it's not really easy. Look at this one. 1,2,5, which means there are two hydroxyl group. Di means two hydroxyl groups in the vitamin on the places of carbon number 1, 2, and one is on the carbon number 1 and other is on the carbon number 25. So there are two hydroxy group on carbon number 1 and carbon number 25 in the vitamin D3. All right, so vitamin D active form is 1,25 dihydroxy D3, which is active form. So right, so in the skin, all right, I have written in the skin, this vitamin D is actually in the form of 7-dehydrocholesterol. So this 7-dehydrocholesterol is actually going to be converted into vitamin D3. This vitamin D3 is going to be converted into the vitamin. It is going to be converted. Vitamin D3 is, skin 7-dehydrocholesterol converted to the vitamin D3. D3 is going to be converted to the 2,5 hydroxy D3, and again this is going to hydrolyze. There's a two-process hydroxylation of D3, so this is again going to convert into 1,2,5 dihydroxy D3 active form, which is also the last stage. So vitamin D, after 2 hydroxylation, you can say, is going to convert into the active form, which is this one. I'm writing in the active form AF, which is this one, 125 dihydroxy D3 active form. Right, and skin is present in the 7-dehydroxycholesterol. You have heard of it by the doctor that you have to sit in this under the sun in the morning time or in the evening time. That means that you have to get the sun, which actually is sunlight, or there are particular rays which actually convert the skin 7-dehydrocholesterol, which is present in your skin, converted into the vitamin D3, that is simple D3, or you can say cholecalciferol, and which is actually going to vitamin D3 is going to be converted to this process finally into the active form 125 through the hydroxylation process. So the main function of the vitamin D is really main function is maintenance of plasma calcium level. So one thing I have to tell you before talking about the maintenance of plasma calcium level, you have to remember the vitamin D is the most toxic of all the vitamins, because if vitamin D is increased, it's going to create a problem. If it's going to decrease, it's also going to create a problem. In both cases, this guy is going to create a lot of problem because it maintains the plasma calcium level. So when you require more calcium, if you have deficient of calcium, it is going to take the vitamin. What happens? The calcium is going to come from your bones. If it is, vitamin D actually helps in the absorption from your intestine, the absorption of the calcium from your intestine, and also help in the from the retention from your kidneys. So you can simply remember it by this one, that it maintains the plasma calcium level. Also, the parathyroid hormone plays a big role in the maintenance of this guy, calcium, in the plasma. All right, we're talking about only plasma. We're not talking about bones. Remember this one. And one thing in the last, we have to remember that in the deficiency of vitamin D, we are going to rickets. Rickets is actually in the children, or you can say rickets caused in the children, weakness of the bones, but osteomalacia in adults. So if somebody asks you in which case the bones become much softer, easy, you would be saying rickets. No, it's not rickets, it's osteomalacia, which is in adults. So adults, what happens in osteomalacia? There's a demineralization of the vitamin of the calcium from your bones. All right, so this is it regarding all the vitamins. So I hope I had clear all the ideas to make it easy as possible. If you have any queries or any question, if you think I have made a really little bit silly mistakes, please do make sure to write them in comment and let us know what would you like a lecture on, and we will try to make it as easy as possible. Thank you, and keep visiting Tides Schooling.